This video demonstrates a proof of concept of a motion tracking device using deep learning. It uses 6 MPU 6050s, one on the head, 2 on the elbows, 1 on the waist, and 2 on the knees, to classify movements into 5 different categories, specifically going downstairs, sitting, standing, going upstairs, and walking. Right now it's a proof of concept because the I2C connections are currently unstable and no data is being received from the MPU 6050s on this current device, and also several of the pin connections on the PCB have broken. However, data is being received as all zeros currently. The lack of I2C does not break the code. So when I power it on, the MPU's power on, as well as the Bluetooth transmitter. The Bluetooth transmitter sends data from the MAX 78000, which runs a neural network plus input processing, to my phone. So if we go to the Bluetooth app, we select DSD Tech HM20, which is the Bluetooth device hooked up to the MAX 78000. And we can view the data that's being sent. So the first 36 values are basically saying that there's no data being received from the MPU 6050s. The next six values are error codes. The 7 in the middle shows that the head is currently disconnected. That's because one of the pins for the head is broken off. And then the final 2s is just buffer. But even then, it sends a list of 5 numbers. It reads 1, 13, 0, 9, and 9. That's the output classification of the neural network on the device. The neural network is a very small AI85 net. It has five layers, 2 convolutional transposed layers, 3 convolutional layers, and a fully connected layer to classify into 5 different classes. The input is 3 seconds worth of input data. So each input is sampled over 10 milliseconds, and a frame would consist of 60 milliseconds for reading every single MPU 6050. It takes 30 of these, which would take around 3 seconds, and puts them into a single input, and that creates a classification. Then it's updated every second, so it's a rolling stream of input, and the classification happens every second, but the neural network happens in serial, so it has to run really fast, otherwise it'll delay the handling of inputs. Therefore, I chose a very small network. It takes up less than 3% of the processing and memory space. And it has 8-bit quantization with approximately 97% accuracy. In this case, with all zeros as input, it classifies the action as sitting. So if you are able to see it in the scrolling, it says you're probably sitting. The values of the classifications are 1, 13, 0, 9, and 9. The first value is going downstairs. The second value is sitting. The third value is standing. The fourth value is going upstairs, and the fifth value is walking. Part of the reason that going upstairs and walking have high values for all zeros as input data is because I treated disconnects of the I2C as input. So when you're walking or going upstairs, the movement of wires tends to create disconnects. And I took that as input just because it shows up as movement. However, also when you're sitting, the lack of movement causes the delta values to approach 0 as well, which would make sitting in this case a better option than walking or going upstairs. If the I2C connections were stable, this code would run normally and we would see data instead of all zeros. And in that case, it would have differing data than just you are probably sitting and all zeros. So this is a proof of concept for motion tracking using cheap IMUs.